Okay, in this problem we're given a third degree polynomial and we're told to find the zeros. So I recognize that the lead coefficient right there is a 1, that x cubed is the same as 1x cubed, and I look at this 21 and this 1 and I think to myself, factors of 21 divided by factors of 1. And that gives me a list of numbers. It could be plus or minus. Let's see, what are the factors of 21? 1, 3, 7, and 21. And factors of 1 is trivial. So this is just plus or minus 1, 3, 7, and 21. So let's try these. We'll try 1, and we'll write down our coefficients here. 1, negative 9, 11, and 21. So we bring down the 1. 1 times 1 is 1. We add and we get negative 8. Negative 8 times 1 is negative 8. We add and we get 3. 3 times 1 is 3. We add and we get 24. So 1 didn't work. So let's try 3. 1 minus 9, 11, and 21. Just setting up the coefficients there for the synthetic division. Okay, bring down the 1. 1 times 3 is 3. We add and we get negative 6. Negative 6 times 3 is negative 18. We add that to the 11 and we get negative 7. Negative 7 times 3 is negative 21. And we add there and we get 0. So that worked. So x minus 3 is a factor. And then x squared minus 6x minus 7 is a factor. And then this looks like this won't be too hard to factor. So x minus 3, and then let's see if we can factor this as x plus something, x minus something. And it looks like this will work with a x plus 1 times x minus 7, and that does it. So we're told not to find the factors, which we just found, but to find the zeros. So the zeros are, and you can just read them off basically from each factor. X equals 3, x equals negative 1, and x equals 7. So that's the answer. Here's another problem. Find the zeros. 2x cubed minus x squared minus 10x plus 5. So I think factors of 5 divided by factors of 2, right there. Factors of 5 divided by factors of 2. Okay, factors of 5 are just 1 and 5. And factors of 2 are just 1 and 2. And we indicate this because we could have positive or negative factors. So this is plus or minus 1 over 1, 5 over 1, 1 over 2, and 5 over 2. Those are all the possible numbers we could make by taking factors of 5 and dividing by factors of 2. So let's try these. I'll start with 1, and we write down the coefficients here for the synthetic division. 2, minus 1, minus 10, and 5. And let's see if the 2 works. Bring down the, the 1 right here. We bring down the 2. 2 times 1 is 2, and we add and we get 1. 1 times 1 is 1. We add, we get negative 9. Negative 9 times 1 is negative 9, and we add and we get negative 4. So that didn't work. So let's try 5. And set up the coefficients here. And let's see what we get. Bring down the 2. 2 times 5 is 10. We add and we get 9. 9 times 5 is 45, and we add and we get 35, and I'm not even going to bother to finish. We can tell that that's not going to work. I'm going to get some big positive number, not going to get a 0 right here. So let's try the next one in the list, 1/2, 2, negative 1, negative 10, and 5. Bring down the 2. 2 times 1/2 is 1, and then we add and we get 0. 0 times 1/2 is 0, and this looks like it's going to work. We add here, we get negative 10. Negative 10 times 1/2 is negative 5, and we add and we get 0. So that's it. x minus 1/2 is a factor. And then the other one is x squared plus 0x, excuse me, that's a 2 right there, 2x squared plus 0x minus 10. So we're told to find the zeros. So from this, we see that x equals 1/2 is one of the zeros. And from this, we'll get another zero. 2x squared minus 10 has to equal 0. What value for x right there makes that true? Well, let's just figure this out. 2x squared will equal 10. I just moved the 10 over to the right side, and it became positive. And then divide both sides by 2, we get x squared equals 5. So x is plus or minus the square root of 5. And note that that number is not in this list because this is an irrational number. Those still end up being zeros of the polynomial, but the rational zeros theorem helps us find the rational zeros, not the irrational zeros. But let's write our answer to the problem now because we've got it. The zeros are x equals 1/2, the square root of 5, and negative square root of 5.